All right, so we're on lesson 16, understanding box plots. So remember what we've been working on is finding the median being that middle value. And remember, when we're given data, like we're going to see in a moment, we have to organize the data from the smallest to the largest because that is essential for finding that median. All right, so let's see what our first problem says. Exercise 1, Supreme Court Chief Justice. The Supreme Court is the highest court of law in the United States and makes decisions that affect the whole country. The Chief Justice is appointed to the court and is a justice for the rest of his life unless he resigns or becomes ill. Some people think that means that the Chief Justice serves for a very long time. The first Chief Justice was appointed in 1789. The table shows the years in office for each of the Chief Justices of the Supreme Court as of 2013. So if we look over here on this table, right here I see my data. My data being the number of years. Over here is just the year that they were appointed or told that they're going to be the Chief or Head Justice. But my main data is going to be coming from this column. Alright, so our first question says, use the table to answer the following question. Which Chief Justice served the longest term and which one served the shortest? So I'm going to look for my longest first. And I'm going to label it. And I look over here for those longest or the biggest number. And I see right here 34. So I'm going to write down John Marshall. And then my next part of the question says, how many years did each of these justices serve? So I'm going to put that little dash and put 34 and my label being years. So now I'm going to look for the shortest, that second part of the question, for the smallest number. And I see this justice only served for 1 year. So I'm going to label it again shortest. And it is John Rutledge. And again, I need to label it for the shortest number of years being 1 year. Alright, so let's head on down to the next part. What is the median number of years these Chief Justices have served on the Supreme Court? Explain how you found the median and what it means in terms of the data. So I need to head back up and organize this chunk from smallest to largest. Alright, so my first one was a 1, followed by a 4, a 5, a 7, 8, 9, 11, another 11. Oops, and I see I forgot a 6 right in here, so I need to squeeze that guy in. Alright, sorry about that. My dog was not letting me ignore him. So I finished putting them in order. So now I need to find the median, since that is what my question is asking me for. So I'm going to cancel off the ends. So 1 and 1, 2 and 2, 3 and 3 until I get to that middle number. And I see my middle number is 11 years. And if I check, I'll have the same number on the left as I do on the right. So I have 1, 2, 3, 4, 5, 6, 7, 8 data points on the left, and 1, 2, 3, 4, 5, 6, 7, 8 data points on the right. All right, so my median is 11 years. And I'm going to label that. Alright, and then it says, explain how you found the median and what it means in terms of the data. So how I found it is, first you have to put the data in order. There are 17 justices, so the median would fall on the 9th value, so the 11 years starting from the bottom. The median is 11. What that means is approximately, or about half of the justices served less than or equal to 11 years, and half served more than 11 years. And that time was my cat walking on my surface. Alright, so our next question says make a dot plot of the years the justice served. So my first step is I need to make that dot plot. So I have starting at 0, since my minimum value is 1, so I'm going to start at something extremely close to it. It's going to go up to 34. So I'm going to make mine go up to 35. Since that's a nice even, or not even, but a nice friendly number, since it's a multiple of 5. And I'm going to label them every 5 digits. So 5, 10, 15, 20, 25, 30, 35. So remember, when I'm finding my values for dot plots, I need my median, which was that 11. And now I'm going to find the quartile 1. So I look in this lower half. And I'm going to find the median of this lower half. So 1 and 1, 2 and 2, 3 and 3, and I have 2 of these values. So remember, when I have 2 values that are in the middle, I add them together and I divide them by 2. If I'm really good at my math, which I hope you all are, I can also figure out in my head what's exactly between 6 and 7, which would be 6 and a half. If I'm not sure how I got that though, I do my division steps, add that 0 to bring down. So I see it's 6 and a half. So that 6 and a half is my quartile 1. I'm going to do the same thing with my upper values, find the median. So 1 and 1, 2 and 2, 3 and 3, and I have these 2 together. So same thing, but this one I can recognize. What's exactly between 17 and 19? I know it's 18. If I'm not sure, again, I can add these 2 together to get that 36 and divide by 2, which will give me that 18 as well. So my quartile 3 is that 18. So now I have all my data. So I start my box plot with that 1. So it's going to start right here, and I label it with that dash. And 34 is my max. And so I label that max with that line as well. I'm going to find quartile 1, which is 6 and a half. Which will probably be right here, and it's going to be a little bit bigger because remember, it's going to be a box for that middle chunk. And quartile 3 is 18, so I make it bigger and I connect that box right there. Connect the box to my max value, the box to the min value. And the last thing I need to add is that original median. So that original median was an 11 right there. Alright, so I've done this part of make the dot plot, or make the box plot. Now it says describe the shape of the distribution. So my shape of the distribution seems to have more justices serving a small number of years on the lower end. So that's my shape. More justices are serving on the lower end because it is below that median. Alright. The next part says, and how the median, so I can't forget this part, and IQR relate to the box plot. The range is 33 years, so my interquartile range is not my first part I'm going to state. So my range is the min minus the max. It's 33. But it's asking me to focus on that interquartile range instead, which remember is Q1 and Q3. So my interquartile range is 18 minus 6 and a half. When I subtract those two, I'll have 11 and 5/10. So that is my IQR. But my question is, how does those two relate to my box plot. So my IQR says about half of the Chief Justice had terms in the 11.5 interval from 6.5 to 18 years. So half of my Chief Justices are in this area. Alright, on for D. Is the median halfway between the least and most number of years served? Why or why not? So the halfway point on the number line between the smallest number of years served, being that 1, and the greatest number of years served, being that 34, is 17.5. So that 17.5 would be my mean. But because the data is clustered towards that lower end of my distribution, so since it's clustered more towards this area because it's smaller, that means more data is together, the median 11 is to the left of where that mean should be, or that exact middle part, not the mean, I'm sorry. The middle of the interval from the smallest to largest data has no connection to the median. The median depends on how the data is spread out over the interval. So the main part I want to take away is the median. What we've been working on for that box plot is related to how spread out it is. So here we see it's clustered. Here we see it's very spread out. So since it's clustered on the left, it's going to be further away from that exact middle point between 1 and 35. Alright, I know that was hard, so let's head on to our next one. Downloading songs. A broadband company timed how long it took to download 234 4-minute songs on a dial-up connection. The dot plot below shows the results. So you may not know what a dial-up connection is, but that is irrelevant to our problem. But we can see down here, these data points seem like a much better time than these, because to download 232 songs, some people only did 5 minutes, but some people were over 17 minutes. So our first question, question A, says, what can you observe about the download times from the dot plot? So the smallest time was a little bit less than 5 minutes, and the largest is a little bit more than 17 minutes. Most of the times seem to be between 8 and 13. So that's where most of my data is. So question B says, is it easy to tell whether or not 12.5 minutes is in the top quarter of the download times? So remember, it's that top quarter. So that top quarter refers to Q3. So do you think it's above that Q3 value? And just by looking at it, I cannot tell. Alright, so now we're on to C. The box plot of the data is shown below. So here's my box plot already made for it. Now it answers part A and B above using the box plot. So I'm going to use this fella to answer A and B. Alright, so answer for part A was based on the box plot. About half of the times are above 10.6 or 10 and 6/10. So half of my data is above that median. If I look up here, it looks like it might match as well, because 10 and 6/10 would be split right here. And that looks kind of like half the dots are above. Alright, the distribution is roughly symmetric around the median. So if I look here, it looks like about the same shape, the same length. If I look up here, it looks about the same. There's a little dip. Wasn't the perfect one, I'm sorry. But then they go straight up. Question B, is it easy to tell whether or not 12.5 minutes is in the top quarter of it? So if I look right here, this was my Q3 line. And does it look like the 12.5 would be above that Q3? So the answer is yes. 12.5 would be above that Q3. Alright, so now we're on to D. What are the advantages of using a box plot? So what are the advantages of using this instead of a dot plot to summarize a lot of data? So there's many possible answers. With lots of data, the dots in a dot plot overlap, and you can see general patterns, but it gets really hard to tell anything about the actual numbers since there's so many dots. The box plot shows at least an approximate value for each of the 5 number summary measures and gives a pretty good idea of how the data is spread out. The disadvantages, since it's asking for that as well, is that specific values in the data set are not given. So I cannot see in my box plot how many 9.5s there are. I don't even know if there was a 9.5. I just know if there was, it would be in this area. Alright, so now let's head on to number 3. So Molly presented the box plots below to argue that using a dial-up connection would be better than using a broadband connection. She argued that the dial-up connection seems to have less variability around the median. So here's my key. Less variability around the median. It's talking about that dial-up connection. Even though the overall range seems to be about the same for the download times. So we're saying my range is the same. So not interquartile range, but the range. And range, if you remember, is the max minus the min. So she's saying the maximum value minus the min is about the same, but there's less variability around the median for my dial-up. What would you say? So the first thing I should notice is this. The scales are different. This one is every half second, so 1.5 seconds or 1 5/10, 2 seconds. Well, here this is in minutes. So the first thing I can tell her is my scales are different, so I can't look at just the box plots. The time using broadband is centered near 5 seconds to download the song, while the median for dial-up is almost 11 minutes. So here I see 5 seconds since the scales aren't the same. And here I see almost 11 minutes for their median. This suggests that broadband is going to be faster than the dial-up. So the thing we want to take away is it is different if the units are not the same. So now let's go back to her question. She argued that the dial-up connection seems to have less variability. I can't argue for or against that because it comes back to those units not being the same. Alright, exercise 4. Data on the average rainfall for each of the 12 months of the year were used to construct the 2 dot plots below. So I have a dot plot for St. Louis and a dot plot for San Francisco for rainfall. How many data points are in each dot? And what do each data point represent? So right here, since it says the 12 months, I know that there are 12 data points for each. And then each dot plot represents, because that's my second part, each dot represents a month of precipitation. Alright, for B, make a conjecture or an educated guess about which city has the most variability in the average monthly amount of precipitation, and how this be reflected in the IQRs for the data from both cities. So San Francisco is going to have the most variability because it has data that is more spread out. So since it has data that is more spread out, that means San Francisco, abbreviated San Fran, is going to have a larger IQR. Alright, for C, based on the dot plots, what are the approximate, so approximate means it doesn't have to be exact, values of the IQRs for the average monthly precipitation for each city? So I need to find those IQRs. What I'm going to look for is, since there's 12 data, it's going to be split at about 6 for the median, and then about 3 and about 9. So about 3 for St. Louis would be maybe 3 inches, and about 9 would be about 4 1/4. So if I subtract those two for St. Louis, that's going to give me 1 1/4 or 1/2500 of an inch. For San Fran, again, since it says approximate, I'm going to look for that third one about, and the 9th one. And so I'm going to do, that's a super tiny value. It looks like it is 0 200ths. And I'm going to subtract it from 3 4/10. I'm sorry, I said 200ths. It should have been 2/10, which will give me about a 3 2/10 for an answer. So I found an approximate. Use the IQRs to compare the cities. So now I'm ready to compare them. In San Francisco, the middle half of the monthly precipitation amounts are within about 3 inches of each other. So there's going to be a lot more greater variability within that San Francisco than we have in St. Louis, since it has that larger IQR. So my comparison is there's going to be much more variability in San Francisco. Alright, for D, we're going to skip it because of time. And now on for 5, which is our last one. Use the data from exercise 4 to answer the following questions. Make a box plot of the monthly precipitation amounts for each city using the same scale. Alright, so this one I have St. Louis. So again, I'm going to look for that minimum value. So St. Louis, and I'm going to erase our work here. My minimum value is 2.5. My maximum value is about 5. So minimum, maximum. I need to find my median. Alright, and my computer is running out of its battery, so that's actually going to stop us for today.